All right, so here is your notes unit 3.3. We are graphing in 3 dimensions. Objectives today, we got 3 of them. Be able to identify characteristics of dimensions. This is just, identification, so just kind of knowing what they are. Be able to plot a point in 3 dimensions. So this is one of the main objectives for today's. You have to plot a point, but not just an XY point. It's actually going to be a triple, ordered triple, because there's 3 dimensions, X, Y, and Z. And then be able to graph a plane in 3 dimensions. A plane in 3 dimensions is similar to what a line is. So when you graph a line in 2 dimensions, the equivalent of that in 3 dimensions is basically going to be a plane in 3 dimensions. Okay. So don't write this. 0 dimensions. 0 dimension means it's a point. So anything that lives in the zero dimension is a single point. First dimension means you now have some movement. Now you can only move going one way. So it's either going to go side to side or up and down, not both at the same time. So first dimension stuff has to go along a straight line, and that is it. Second dimension, now your point, so you're basically, what I mean by that is your point can end up anywhere along on this line, and you can draw anything using points along that line. Second dimension means that your point is now allowed to move side to side, and it's allowed to move up and down. Ooh, that was a bad line. So basically, this is what we're used to, so we can move our point 3 to the right and then 2 up, so our point can end up here. Our point can end up here, our point can be here, our point can be here, our point can be here. Our points can be anywhere along this coordinate plane, okay? Third dimension, now what happens is, not only do you have your point moving up and down and moving side to side, but now you have this concept of it's not flat anymore. It can come off of the screen. So this is kind of hard to describe on a video because a video screen is flat. But basically what happens is your point will move, say, 2 to the right. And then you can move your point up 2. And then imagine the point coming off of the screen towards you, however many units. So let's say that your point was at 2, 5, 7. So basically what would happen would be your point would move along this 2, then it'd go up 5, and then it'd come out towards you 7 units. So that's what would give it like that. But now since I have to draw this, I can't really draw an axis coming off of the screen. So what I got to do is make my axis like that, and then it's up to your imagination to see it coming off of the screen. You're either going to see it or you're not. It's not really anything I could teach you how to see. It's just basically the way your brain works. Either you can see it or you don't. So now if you don't see it, like I said, I can't really teach you how to see it, but what you need to focus on is the procedures that I'm about to show you. So follow the steps that I'll show you even if you don't really see it, okay? Dimensional glasses, we talked about that in class. Let's see if I can pull this thing up. I had this up before to help you guys see what I'm actually talking about. I think it takes a while for it to pull up, so I'll come back to it. So practice drawing axes. So like I said before, what you're going to do is to draw these, you go up and down, then you go side to side, and then you draw a third axis coming this way. Now, this is going to seem kind of strange, but, whoops. Oh, this is the place, okay. I accept the risk. Let's go ahead and run it. Error, click for details. Details. So let me pause this while I get this. Okay, so this is what was trying to bring up. If you go here to this website, there's actually a 3D graph you guys can kind of mess with. Now, it's kind of light, but if you can see, you actually have an axis here. They call that the z-axis. They call this the x-axis. They call this the y-axis. Now, the reason why ours is a little different is because technically you can tilt this any which way you want and have your x, y, and z-axis kind of come around to be wherever you want it to be. So this is what we're going to try to accomplish drawing, is a plane in 3-dimensional space, okay? So it's probably a better representation of it, okay? So we got our 3D graph, the x, y, and the z axes. I'm just kind of spinning it here. And you have this green part. Now, if you notice, the green part's made up of actually a whole bunch of lines netted together. So this is our representation of a bunch of lines in 3D space, which makes a plane. Every graph, every shape that you graph in 2-dimensional space has a representation in 3-dimensional space. Kind of like a parabola. So right here. So if you know what a parabola looks like, it's y equals x squared. Now we got a z squared also. So this is a representation of that. Okay. Now, if you notice, these all have the little parabola shapes, but they're all netted together. And now it froze. Let's try to reload that. Okay, and there you go. Okay, so that's what a parabola looks like in 3D space if you had a parabola type equation, or the equivalent of one. Okay, we're not going to get to this like this far in the graphing, but this is what this type of stuff leads to. And some of you guys might think this looks familiar because if you've seen like the behind the scenes type stuff in Pixar films, or any type of computer generated special effects, it looks similar to this because they're doing mapping in 3D space with computers. So all we're doing in this class though is doing the very basic, just knowing how to plot a point. And then from plotting a point using higher level math, you can get to things like this. So feel free to go to this site, kind of mess around with it so you can get a better idea. All right, so drawing the axes. So if I'm going to provide you guys with graph paper on my website, so just go to my teacher webpage and then get it. If you're not given graph paper, basically what you're going to do is this. You're going to draw one line going up and down, one line going side to side, and one line going this way. This line represents it coming out towards you. Now what you're going to do is you're going to make the marks on your graph. Very similar to how you used to make your marks when you had just an X and Y. You just made your marks like this. Now, if you notice, those marks run parallel with the other axes. Axis. Yeah, axis. Sounds right. Axis. Okay, so when you make your marks on your graph, you need to make sure that they run parallel with the other one. Okay, so I just set my ruler parallel to, oh, by the way, this is considered your x-axis. This is considered your y-axis. This one's considered your z-axis. Yeah, that's how most books label those. As it comes out this way, this is actually your positive x values. These would be your negative x values. These would be your positive y values. These would be your negative y values. These are your positive z's. These are your negative z's. All right. To make your marks, basically just line your ruler up with one of the axes. Usually you want to make your x and your y axis marks parallel with each other. So right now my ruler is lined up parallel to the x-axis. Now I'm going to move along my y-axis and make some marks. These marks will help me plot points. Sorry, they're kind of crooked, but basically that's it. That's how you make your marks on your y-axis, and you can go a little bit in the negative direction. Okay, then that's how you make your marks. Now, if I want to make marks on my x-axis, I'm going to tilt my ruler until it's parallel with my y-axis. Okay, so it's parallel. And now I'm going to make my marks along my x. Ooh. Okay, and you can do a few to the negative. Now your z-axis, you can put that parallel to your x or your y. It's just a matter of preference. I like making my z-axis parallel to my y-axis. And then I just make them side to side like this. Okay. So now the problem with this is that just like with anything else, not anything else, but just like with the graphs like this one, it's easier to do on graph paper. So here's where you guys can print up some graph paper to help you with this next part. It's called isometric graph paper. Now, this graph paper looks like this. Instead of going out and buying some, there is a website that has them. So here's the website. It's called printfreegraphpaper.com. Go here. Now, you don't need to print like a whole bunch of them because we're not going to be here on this section that long. But basically, Cartesian graph paper looks like this. I want you guys downloading some isometric graph paper, which looks like this, okay? Make sure you have regular letterhead, inches, and then maybe do 1/4 inch so you can fit more on there. Hit print, and then it'll have this thing for you to print up, okay? I'll put a PDF file of this on my website too, but I mean, you can always just go here by yourself and get that downloaded, okay? So moving on. So the way you're going to draw your axes on this is you're going to pick a point. So first, pick a point where it almost looks like, if you consider these kind of like little boxes inside of here, it's almost like it's on the corner of one of the boxes. That's going to be your origin. So your next step is to basically just draw a line going through the origin this way. Draw another line going through the origin this way. Okay, see how they cross? And then you also have a third line going up and down like this through the origin. And that went kind of weird. Okay. This is your x-axis, this is your y-axis, this is your z-axis. Positives come out this way, negatives go back this way, positives are here, negatives are here, positive z's, negative z's. All right, and then the nice part about this is that when you make your marks on your y, you can now just follow the lines that are actually already on there, because those are already running parallel with the x. Same thing with the x, you can make your lines parallel with the y, because you can already see them. Now the Z, you can run them parallel if you want to. I like to make mine just go side to side. It's just a matter of preference, really. These are three-dimensional drawings, so it's optical illusions anyways. So I just like making mine go side to side like that. And underneath this part was actually just a nicer drawing of it. Okay? So you should end up like this. So positive x values this way, y values that way, z's up and down. So let's practice plotting points. To plot a point, I'm going to go back to 2D here. This is your x, this is your y. So 2, 3 meant you went to the right 3. I'm sorry, 2, and then up 3. Some teachers, when they first taught you this, they actually said, go right 2, and they actually drew an arrow to the 2, because x2 means go right 2. And then they said, go up 3, and they actually drew an arrow going up to the 3. And then they said, okay, that's where your point is. Your point started at 0, it moved to the right 2, and then it moved up 3, and then your point ended up right there. That's the method that we're going to use to draw points on 3D. Okay, so 2, 3, 5. Now, it's harder to draw on here because you have to imagine the lines keep going. This is a little bit easier, so I'm going to do it on this isometric graph right here. So if you have a graph paper, you should start this on there now. If not, pause it, go get the paper, and start after you get the paper. All right, so x is 2. I know this is my x-axis, going out positive this way, negative this way. So since my x, y, and z, positive y's, positive z's here. Okay, so x is a 2, so I'm going to run along my x-axis 2 units. A unit is basically like one of these boxes. So there's 1 unit, and then I'm going to go out another unit to right here. That is 2 units to the x-axis. The y-axis is a positive 3. This is your y-axis right here. So a positive 3 means 3 units along the y-axis, which are these lines right here. So there's 1, there's 2, and there's 3 along the y-axis. Last movement is with the z-axis. Now the z-axis goes up and down. Now you're not going to try to line it up with the 5 mark up here. Okay? What you're going to do is you're starting here. You're just looking at these boxes right here, and you're going to go up 5. So I'm going to go up 1, 2, 3, 4, 5. Okay? So my point traveled along this route. It went this way, and then it went up 5, and my point is now right there. The only part that I'm worried about is the point. All those arrows is just helping me grade your paper. All right? Okay, moving on. So trying this one. Try this out. Pause the video, try it out, see if you get the right answer. I'm going to go ahead and put the answer on, though. This is your x, y, and z. So x is negative 3. So this is your x, y, z. Negative x value means go backwards. So it's going to go back 1, 2, 3. So right now you're right there. Then you're going to go along your y2. Positive y value 2 means go this way 2. And then your z is a negative 4. So I'm going to drop it down 1, 2, 3, 4 to right here. Your point ends up right there. Okay? Oop, bell. Oop. That's my impersonation of a bell. There was obviously no pair share. 2 points make a line, 3 points make a plane. We are graphing a plane. I went over this in class, so I'm not going to go too much detail. Graphing an equation in 3D is similar to how we graph the standard form in 2D. So if we want our x-intercept, y-intercept, x-intercept, so for x, you plug in y is 0, so that makes the 0 basically go away, equals a 12. 2 times 0 is 0, 4x plus 0 is 4x. So x-intercept is x equals a 3. Okay, so this point is 3, 0. Plotting that point, 3, 0 is right here. Okay, y-intercept is a 2y equals a 12. Y equals a 6, so your y-intercept is 0, 6. So 0, 6 is up here. And then you were supposed to draw a line connecting the 2 points. If I can draw a line, that would be great. All right. And that's how you guys are supposed to graph that. And the arrows indicate they go on forever. We're going to take a similar approach to doing 3-variable graphing. So 2x plus 3y plus z equals 6. So with 3 variables, we got to find 3 intercepts. So same deal here. You're going to plug in a 0 for y, 0 for z to get your x-intercept. So you're going to end up with a 2x equals 6. For your y-intercept, you're going to plug in a 0 for everything else except for y. So you end up with a 3y equals 6. And then for your z-intercept, which is your new intercept, you plug in 0 for x and y, you get z equals 6. Okay, so solve this one, you get x equals 3. This point is an ordered triple. X is 3, y was 0, z was 0. Oops. Y equals a 2, x is 0, y is 2, z is 0. And z equals 6 is already solved out, so that's going to be 0, 0, 6. So notice we have 3 points here. This is our first point, second point, and third point. You do not, I repeat, if you put 3, 2, 6, and then plot that point like we just learned how, you are incorrect. Warning, warning, do not do, stop, please, or I'll throw my shoe at you. Hey, that rhymed. Okay. So let's plot these points. Okay, so first point is 3, 0, 0. So just like before, I'm going to start by plotting this point. So this says move along your x-axis 3, don't move along your y-axis, and don't move along your z-axis. So if I move along my x-axis 3, I end up right here. Okay, so that's moving along my x-axis positive 3. Now I'm going to plot a brand new point, start at the origin, and I'm going to move along my y-axis 2. So start here, then you're going to move along the y-axis 2 to right here. Okay, and then last step is to move your z-intercept up to 6. So you're going to move up 1, 2, 3, 4, 5, 6, which is up here. So now that you have 3 points, the next step is to just connect them. And connect 3. When you connect 2 points, you make a line, but when you connect 3 points, you actually make a triangle. And that represents the flat surface of a plane. Next step is actually you're supposed to shade it in. And then that's that picture. Let me shade it in with a different color. Okay, and that's how you do that. Let's see if I had another example. Okay, so let's try this one too. So try this one on your own. Go ahead and pause the video if you want to, and then try it on your own, but I'm going to do the answer right now. So make sure you identify your x-intercept, your y-intercept, and your z-intercept. So x-intercept is 3y equals a 12. Your y will end up being a 4. Whoops, that turned into a y. That's supposed to be x. Okay, so it's a 4, 0, 0. Y-intercept is 2y equals 12, so y equals a 6. This is 0, 6, 0. Z-intercept is a negative 4z equals 12, so z equals negative 3, 0, 0, negative 3. Alright, so now we're going to graph these. So 4, 0, 0, that goes along the x-axis 4. So 1, 2, 3, 4. Y-intercept's at 6. So along your y-axis, we're going to move 6. 1, 2, 3, 4, 5. Oh, so way over here, 6. Z-intercept is a negative 3. So this is my z-axis. Negatives go down. So 1, 2, 3. There's your third point. Now it's just a matter of connecting your points. Make your triangle. And then shade it in. And that's how you plot points and graph planes in a 3-dimensional plane. For your homework, just look on the school website, look up my webpage, and you'll find a worksheet as well as some graph paper for you guys. Okay, bye-bye.